The figure on the left gives you an idea of what the picture looks like, and we know that the vector C, the resultant from the start point to the finish point, is the vector sum of vector A and vector B. And we have two methods that we can use to find the answer to this problem. The first method we will talk about is using the components method. And this is something similar to what we've just did in example 3. We notice that vector A is purely on the horizontal axis, so we can say that it's 100 meters in the I hat direction and 0 meters in the J hat direction, if we use J to be the north and I to be the east. And then we can say that vector B is 200 meters with a cosine of, notice that if this angle here is 45, then the angle that vector B has would be 180 minus 45, or 135 degrees. This will be the magnitude of the I hat component of vector B, and then similarly it would be 200 meters times the sine of 135 degrees in the J hat direction. So that means that vector C now excuse me, is going to be vector A, which is 100 meters I hat plus 0 meters J hat, is going to be added to this vector B, which is 200 meters cosine of 135 degrees I hat plus 200 meters times the sine of 135 degrees J hat. And if we look at vector summation, we notice that we can add the I terms together and we can add the J terms together. This is what you've done as combining like terms in your algebra class. And if we do that, we get that vector C is going to be 100 meters plus 200 meters times the cosine of 135 degrees in the I hat direction, and it's going to be 0 meters plus 200 meters times the sine of 135 degrees, and all of this in the J hat direction. And if we do that, we find that we get a negative 41.1 meters in the I hat direction and 141.4 meters in the J hat direction for vector C. And now one thing we can say is that the magnitude of vector C, notice it's a vector without the arrow, is the square root of the square of its components with the square root taken at the end. So this is similar to the Pythagorean theorem. And notice that we need about 4 significant figures for this. So we can do, this is the same as the square root of 21,720 for inside the square root. And if we take the square root of that, we get about 147 meters. And now the angle that this vector C makes is going to be the tangent inverse of the y component, or the vertical component, over the horizontal component. Notice that you have a minus in the x direction and a positive in the y, so you know that's going to be in your second quadrant, right? Minus x positive y. So this gives us an angle of 74 degrees north of west. And just to remind you what angle theta was, it was this angle here. And if we notice that since this is, it looks like it's past the first quadrant, so that is good. Now, I said there's two ways we can do this. The second method is actually called the law of cosines, which is something you might have recalled from your trig days. And if we look at the situation we have where we have vectors A, B, and C, and we know this angle is phi, and this angle was 45, I believe, and then we can say that c squared, the magnitude of c squared, is a squared plus b squared minus 2 times a times b, the cosine of 45 degrees. And if we plug in these numbers, we get 100 meters squared plus 200 meters squared minus 2 times 100 meters times 200 meters times the cosine of 45 degrees. This gives us, if we do significant figures, 21,720 meters squared, which implies that C is going to be the same answer as we got before. And furthermore, we can say that b squared, using the other law of cosine but with two different sides, so I'm using now to find b, the angle opposite of b is phi, and that's what we use here, as when we used a and b before, the angle opposite of c was the 45, and that's why we used it in there. And if I plug in all the numbers that I know, I can solve for phi as the cosine inverse of a squared plus c squared minus b squared all over 2ac. And plugging in these values, I get cosine inverse of 100 meters squared plus, keep in mind that c squared was 21,720 meters squared minus 200 meters quantity squared all over 2 times a, which is 100 meters, c, which is 147 meters. Plug that in and you get an angle of 106. And now theta, which is what we're calling the angle here, would be 180 degrees minus 106 degrees, which is again exactly what we got before.